Welcome back to the December of kit builds. Today, my kit build is assisted by Return to Helios Milk Stout from Fort Geary Brewing in Winnipeg. They describe this one as having full-bodied creamy texture, roasted coffee and dark chocolate notes, a light sweetness from the lactose, all around an interesting sounding beer. Very pleasant indeed. So let's bring in the big box of kits here, and I think I'll probably just grab this one off the top, which is the one that Jeff sent me a few weeks ago in a mailbag. It is an interesting kit, not one that I would have chosen for myself, but definitely one which should be spectacular if I assemble it correctly and if it all works the way it's supposed to. So let me just get all this stuff out of here. So here's what we've got for parts. We've got 2 circuit boards. We've got a couple of inductors, one really big one and one smaller one. We have this clear plastic tube, which goes right like that. We have these 5 little metal slugs, which, if this thing works properly, insert somewhere in there, and this coil will attract those and launch them out that direction. I'm not going to name what this is just yet, for YouTube reasons. We'll talk about that later. Anyway, there is a really large capacitor, 1000 microfarads at 100 volts. That is going to dump charge into that inductor and create a massive magnetic spike, which is what moves these things around. And then we have a couple of LEDs, some resistors, some transistors, push button, and other basic components like that. 2 circuit boards, like I said, and an acrylic case and hardware to put it all together. And a set of assembly instructions with a schematic. So not a huge component count. There is a transformer, there is an inductor, 3 volts worth of battery, LED and a Schottky diode there. There's the big capacitor, 2 transistors. I thought I saw 3 of them on the workbench. Oh, we'll figure that out later. And then, what is that? It looks like is it another Schottky diode, or are those Zehners? I don't know the part number. We'll have to look more carefully in a bit. A couple of LEDs, another oh, so there's 3 inductors. Okay. No, there's not. There's only 2, but this one is a transformer with 3 sets of windings on it. So we'll have to make sure we get that in the right orientation. Hopefully these instructions explain how to put it in correctly. Yeah, it looks like it does. Okay, we'll get to that in a bit. Those 2 diodes that I was looking at, one of them is just a switching diode, which probably makes that then the Schottky, and that other one is a 91 volt Zener. Wow. But we'll worry about the rest of these parts once we've started assembling it. So let's get going here. I think I will put this in the direction that has most of the legends and the screen print upright. Not all of them, but most of them. I'll probably have to adjust this later, but whatever. So let's see what order this thing has us building it in. First of all, it wants the resistors put in, which is the order that I would normally do things anyway, so that's cool. 1K, 5.1K, 10K, and 470K. I'm starting to like this kit more and more. It's actually got things labeled, so I don't have to trust my colorblind eyes and these stupid blue resistors and their low contrast bands. So 5.1K goes there. 1K goes there. 470K goes right beside it. 2 10Ks go right here. Get in. And a 5.1K goes down there. And those are one in series with that inductor. These 3 in the base circuit of that transistor, so voltage divider and current limiting. And current limiting for this LED down here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Cool. Let's get these ones soldered down. The board is taking solder quite nicely. So far, based on very little time with this kit, I am enjoying it. It's going together quite nicely. The manual, even though it is a translation, is working quite well. So step 2 is the 2 diodes, paying attention to the negative and positive electrodes. The shaded part is the negative. Useful information. And that is this diode up here and this diode up here. This one's a Zener, which is protecting that LED. And although it is a 91 volt Zener, oh, wait a minute. That is going to be, no, that's going to be lighting up that LED once the capacitor charges to over 91 volts. That's what's going on there. Okay. Without looking at the part numbers, I'm going to say that is the rectifier diode and that one is the Zener, but I am going to zoom in and just make sure that I'm correct. And this is why we don't assume. That is the 91 volt Zener, which is D2, which goes there. Note the band to the left marking. And this one, you can just barely read it, says 4148 on it. Regardless, it goes here with the band to the left. This is indicated on the board. Pays to read the instructions, I guess. I was not expecting the diodes to be the style that they are. You'll learn something new every day. Third step, LEDs. We have a blue one, an orange one, and a red one. Pay attention to the polarity. Yes, always do that with LEDs. As always, when you're looking at LEDs, if there's a little flat spot on the side of the case, that is the negative indication. Also, the longer lead is the positive indication. And that lines up properly on all of these. If you happen to have a tester, you can absolutely test them and just make sure. I'm not too concerned about these ones, but might as well run them through their paces just to be absolutely certain. It's very, very rare, but I have seen the occasional LED that was faulty from the factory, so why not check since we have the ability. So according to the parts list, LED 1 is the red one, 2 is the green one, and 3 is the blue one. But on the board, they're not marked LED 1, 2, and 3. They're marked red, blue, and green. So that makes it even easier. Long lead is positive. That one goes there. Blue, long lead is positive, goes there. And green, long lead is positive, goes there. Just looking at these LED leads, they seem to be a little bit tarnished, so I am going to just daub on a little extra flux for insurance. Normally with flux core solder, I don't concern myself with that too much, but in this case I might as well. I'll just push that one up flush now that it's tacked in place. Get the other one. Come on. Yeah, that's not taking as well as it should. Alright, that's the LEDs. Now this inductor. It's got color coding on it. It even says do it according to the color, but they've got the colors labeled in Chinese. That one I can tell is the red one. These two, my colorblind eyes cannot distinguish them. So after consulting with the people with non-colorblind eyes in the house, I think this goes this way. So the one with the enamel insulation is L3, which has the most windings of anything on the coil. And then the middle one is this one here. And then the bottom one, which is labeled L1, is the one that's physically in the middle on the coil that I've got in my hand, which means I have to reorient these two here, which I'm told are red and kind of yellowy orange. That's this one changed. I hope this is right, because it does matter, because as I said, this enameled one has a lot more turns than either of the other two. I think the trick is going to be to get one side in and then kind of nudge the other one in. And I'm sorry if my hand is blocking your view here, but I don't know that I have a lot of options. Okay, that went surprisingly easier than I thought. So that is sitting fairly straight, and I've got the wires stuck through here. I can get at them. That worked better than expected. Now I just hope that between myself and my color consultant, we have made the right choices. Next in is the big Chungus capacitor, again paying attention to the positive and negative, and then 3 wires at K2 minus, K1 plus, and K1 minus. The big capacitor is easy. There's a negative stripe down that side leading to the shorter lead. And on the board we have a positive here, so that just goes that way. Except for I'm going to bend these down so that it can sit flat to the board, because I think that is what is intended here. So it looks like there's some holes here to put some kind of strapping or whatever to hold that in place. Lots of heat on those big pads with the big heavy wires. There we go. I think I do want to strap that down somehow. Will these little zip ties fit through the holes in the board? Oh, they will. Nice. If this was a low voltage circuit, I would have used a piece of wire there, but since this is going to be closer to 100 volts, I think plastic is probably a better idea. Right, where'd my instruction sheet go? All right, I've got some wires to put in. The kit came with these wires, and this is calling for two negative wires and 1 positive wire. So I think I will just separate these out. I don't know if I want them to stay together or not, but yeah, I think for now I will just leave them together. If I need them separated, I can separate them later. So K1 plus and minus. K, and what was the other one? K2 minus. That, since it only asks for one of them, I think I will strip it out. For now, anyway. Alright, those two. Now then, to the other board. So again, it said pay attention to the direction. Of course. Because this is only a single coil, there are only 2 wires, and they only go on one end. So that goes on this side, which is the side away from that little notchy divoty guy there. So that goes like that. And that makes sense. I'm just going to throw a piece of Kapton tape around this thing just to hold it in place while I'm soldering. I could use Blu Tack, I could use any number of other things, but Kapton tape is convenient, cheap, and it's not going to be damaged by heat should I get too close to it with the iron. So we can see that one wire coming off this coil is connected to those 2 pins, and the other one is connected to those 2 pins. And down here, these 2 pins are in parallel with this one over here, which is just a dead pin, and same thing on that side. So we'll solder the ones that matter down. Actually, I guess I might as well solder them all down just because, and that's taking an awful lot of heat. I guess I will solder down some of these ones over here too. They're not electrically connected to anything, they're just mechanical. I think that should be good. take out 2 new wires and weld them onto the small circuit board and then pass them through to the bottom. So that would be soldering it there and then passing it through there. A string leaf end guiding it in the correct direction. And then same again for the other wire. Alright, next, install the round button on the acrylic shell and pass the 2 wires of the electromagnetic gun coil through the holes in the shell. Oh yeah, I guess we're far enough into this video that I can give this thing its proper name. This is a coil gun. I just didn't want to use that term too early in the video because YouTube, or more correctly, their advertisers, get all stressed about certain words. And yes, I know in some countries it's not a weird thing to talk about, but in some other countries of the world, because YouTube is a worldwide platform, it very much is not something that is commonly talked about. So it is what it is. Keep your political opinions to yourselves. Digging through the various acrylic parts of the shell, this is the only one that has a hole that would fit that push button, so I'm assuming that's where it's going to go. This backing paper can sometimes be a real pain to get off, but I find that a little bit stickier tape can usually pick it up and get it off there. This particular tape is what a hockey player would recognize as sock tape. It is common in my part of the world, maybe not so much in yours. Sometimes you have to find different types of tape, but it's left a little bits and pieces here, which I can usually scratch up with what's left of my fingernails. There we go. All right. I guess the other part to figure out is which side is the inside and which side is the outside of this case. So I don't want to get that wrong. After looking at this for a while, I think this is the orientation that this goes in, with the button up there. And then these 2 wires go through those 2 holes. You can't really see it because it's, transparent acrylic, but that allows this to go through there, and then the mounting holes for this thing will line up with mounting holes in the board. That little notch is over there. Yeah, I think that's the shape. So that just screws on there. And it hasn't told me to put any mechanical fasteners on that thing yet, but let's see what the next step is. Next step, 1 wire of the gun coil is connected to the circular button and the other wire is connected to K2 minus. The other end of the circular button is connected to K2 plus. I'm just going to strip a little bit more of the jacket back on this wire so that I can get it into the switch properly. I like to have a little bit of a mechanical connection like that, rather than just tacking it onto the side of the contact. And then the other wire from the coil goes to K2 minus. That's K2 minus. That was awkward. Now then, what did this say? The other end of the button goes to K2 plus, which is that one there. And again, just like the other one, I'm going to strip a little bit more back. That's got that. Even going to let you see my ugly soldering up close. Yep, those are both solidly on there. All right, one side of the ship switch is connected with K1 plus and the other side is connected to K1 minus. Ship switch. What do you suppose is a ship switch? Oh, a rocker switch? Is that a ship switch in Chinese? Okay. And I guess that snaps into that rectangular hole without cracking the plastic. Cool. And that is these 2 wires, which is, I guess, the main power. And the part description is a hole switch, which is K1, which is down there, which is, in fact, the main power switch. Okay. Interesting naming conventions, but I think we figured out what it means, so we'll just go with it and not be too bothered by it. I've still got an assortment of transistors, an extra LED, and a handful of resistors over here. Let's see what's next. I just reread this, and I missed a step up here in step 3. It did have me to put the LEDs in, but it also said weld in the 9013 triodes, which I missed that. Triodes being, I guess, tubes or valves in English, but in Chinese, I guess those are transistors. I've got 3 of them over here in the parts pile, all of which are 9013s, so I don't have to worry about which one I'm using where. Where are our transistors on here? There they are, Q1 and Q2, and there's only 2 of them shown on the schematic, but they've sent 3 anyway. Nice, I guess. So the flat side on the screen print and the flat side of the transistor correspond. So I'll just bend the legs so that I can make that happen. And again with the other transistor. This would have been easier if I had done it at the correct time in the schedule, but so be it. This is where we are. Although I'm not offended by doing the transistors a little bit later in the kit. These are a very durable type of transistor, but the less time that they spend on the board exposed to all my other shenanigans, probably the better for their long-term survival. All right then, let's put that out of the way again and get back to this. The next step is weld on the battery box, paying attention to positive and negative. It looks like the battery box goes on the component side here because there's the pads and they just splooge on directly. So I think I'm going to shorten those wires significantly, although I will leave myself a little bit of room just to make things easier, and we'll pre-tin the wires and pre-tin the pads. Then I can have my hand free to hold this in place. I won't have to be monkeying with holding everything plus the solder. And it looks like those screw holes there match up with those screw holes on the board, so I'm guessing there's some hardware for that. We'll worry about that when the time comes. Shell mounting. Ooh, screws to penetrate the isolation column, small circuit board end housing. Secure it with nuts. So that will be like that and like that. And into there. And I'll just loosely put the first one on. And then put the other 3 in and then tighten it down. I think that is probably the better course of action here. Alright, that's mounted on there. What's the next in my mechanical steps? 4 corners of the main board. Looks like we get single pass copper columns and M3x5 screws. I think I understand. I have to put this base piece on underneath using a screw there, pillar there, and then out of the available nuts, I think there's only acorn nuts left. So I'm guessing that's what goes there to act as feet. M3 hardware is really fumbly for my big old fingers here, but we'll get there. Okay, that's reasonably secure now that it's done. How does the rest of this go together now? I've still got quite a bit of hardware over here. Secure the bottom shell and 2 side shells with M2 screws and nuts. This is really hard to see when they're photographing clear on a white background, but I should be able to figure it out. If those M3 were fiddly, these M2 are going to be damn near impossible. Anyway, they go like that. and then it tightens up to there. But first, more struggling with this stupid cling, sticky protection film stuff. I'll be back. Not a single one of those came off in one piece. Who would have thought that taking the coverings off the plexiglass was going to be the hardest part of this kit? But I persevered. Now the next fiddly step is getting these M2 screws dealt with. I think the move is to start that, then I'm going to slip that over there and onto there, and then screw that down, I think. Do I need a different screwdriver bit, or is that one going to work? There. Now just repeat that a bunch more times.
A little later.
Alright, that's that bit done. Now, clamp the battery case inside the bottom housing and secure with an M3 semicircular cover. That's where the acorn nuts come in that I already used over there. Okay, next. Take out the other two side panels, line them with the holes, and stick them inside the bottom shell. So that looks like, that just goes like that. Oh yeah, that was easy. And then same again there. Okay. And now that goes on top, I guess, and just notches into all four sets of those. Yes, it does. No, it doesn't. Yes, it does. And then they go together with more of this little business here, which is going to be a trick. I'm not sure if I want to let you watch me do this, or oh, it's only just worked. Really? All right. Now to just repeat that one more time over here. And can I get that without dropping the little nut inside? I think I got it. I think so. Yes, it's working. I think I'm finished, at least with the case. Now I have to use some of the double-sided tape. Is there double-sided tape in this kit? Oh, there is. Okay. Use half of the double-sided tape and stick it 1 centimeter from the gun muzzle. So about half of the tape. So 1 centimeter from the end, which is about there. From back to front, slowly fix the barrel inside the electromagnetic coil. So that needs to be sitting that way, and from back to front, insert it that way. So I think that looks very much like the picture. And if we did everything correctly, it should work. Which leaves the last step. Put the projectile into the barrel, turn on the power switch, turn on the blue light, press the round button, you can launch. The blue light is LED 3, which is the one that comes on when that Zener's voltage is exceeded, which is the one that means that the capacitor is charged up to over 91 volts. Well, 91 plus the 3 volts of the LED, so 94 volts, give or take. No other test procedures or anything else. Stuff a couple of batteries into here and see what happens. Is that switch on or off? I think it's off now. Let's put those guys in there. Oh, we have a power light. Okay. So turn that back on again and watch for the blue light to come on, which it is. Let's set up something to shoot at, the box that it came in. Put that in the back and cross your fingers, cross your eyes. It worked! It's not the most dangerous gun in the world, but that is fun. It was electrically an easy kit to put together. Mechanically, that's where the challenge in this thing was. Thanks, Jeff, for sending that over. I do appreciate that. the hardest part of the kit, like I said, was the mechanical. Actually, the hardest part of the kit was getting this damn stuff off the acrylic. But beyond that, just figuring my way through the instructions and their bad translations. I'm glad I was able to find that web page, that sales web page, which I will put a link to down below, by the way. I'm glad I was able to find that so that I could have some reference. That aside, we got done. It works. And I have a fun little desk toy to play with here. Can I shoot at my cats? Oh, you little cowie cats. You've been playing with those projectiles back there in the back corner just like cats do. And now you're happy to be my targets. Blah. Anyway, thanks for watching. Thanks, Jeff, for sending me that. That was fun. And I think I'm going to have fun with it in the future, too. And there is quite a bunch of extra bits and pieces were in that kit, too. So if you drop some of these tiny screws on the floor or whatever, they're still available. There's still extras there. There's at least one each of the other resistors. There's one more transistor. There's one spare green LED. Yeah, I think minus the instructions, this was a good kit, and I think I could recommend that. Thanks for watching. Questions or comments down below. I'll talk to you next week with another kit build.